Welcome to this video on FTTH planning and design in GIS. This is an introduction to the process of deploying fiber-to-the-home networks. FTTH, or fiber-to-the-home, involves running a fiber optic cable directly from the internet service provider to a home or business. FTTX is a broader term covering various fiber infrastructures, including FTTH, FTTP, FTTC, and FTTN. Key FTTH equipment includes the central office, housing the optical line terminal, or OLT, and the fiber distribution hub, or FDH, which uses passive optical splitters. Splitters are passive devices that divide one signal into multiple outputs. Conduits protect the fiber optic cables. Other essential components include the high-speed optic fiber cable, the optical network terminal, or ONT, installed at the customer's location, the handhole for underground access and maintenance, and the joint closure, or JCL, which protects cable splices. This diagram illustrates the FTTH concept, showing the connection from the substation to the JCL, the distribution cable routing, and finally, the drop cable connecting to the customer premises. The first step is a feasibility study and site survey, which includes demand assessment to justify investment, a detailed field survey of the terrain, and an infrastructure review of existing ducts and rights-of-way for optimal routing. Next is network architecture design, or high-level design, HLD. This defines the fundamental network structure, including GPON topology selection, strategic OLT planning, and defining split ratios for efficient subscriber service. Step 3 is detailed route planning and low-level design, LLD. This involves precisely mapping the exact fiber paths, planning the placement of ducts and handholds, and identifying optimal locations for fiber distribution hubs and distribution points. Step 4 is BOQ preparation and cost estimation, which is vital for budget control. This includes calculating material costs for cables and components, labor costs, and project overheads like permits and contingencies. Regulatory compliance and approvals, Step 5, is critical to avoid delays. This involves securing no-objection certificates, obtaining legal excavation permissions, and ensuring compliance with local and national telecommunications regulations. Step 6 is civil works execution, the physical groundwork. This includes trenching for underground infrastructure, duct laying for cable protection, placing handholds for access, and backfilling excavated areas. Fiber cable laying and splicing, or OSP, is Step 7. This involves deploying cables along planned routes, sealing and protecting splices in joint closures, and integrating the cables into fiber distribution hubs and distribution points. Step 8 is equipment installation for both inside plant, ISP, and outside plant, OSP. This involves the setup and configuration of OLTs at the central office, deploying optical splitters, and installing ONTs at customer premises. The final stage, Step 9, is testing and commissioning. Rigorous testing ensures performance, including OTDR testing, power levels verification, and end-to-end link testing. The process concludes with service activation and documentation. GPON, or Gigabit Passive Optical Network, delivers high-speed internet, voice, and video over fiber. Key features include gigabit speeds, a passive network with no powered field elements, efficient bandwidth sharing, and cost-effectiveness for triple-play services. FTTH network architectures include point-to-point with dedicated fiber per user and point-to-multipoint, which uses passive splitters, like in GPON. Networks can also be active, AON, with powered switches, or passive, PON, with no powered field elements. FTTH network topologies include the tree topology, a simple and cost-effective hierarchical layout. The ring topology provides redundancy with a closed loop. The mesh topology offers maximum redundancy, but requires more cabling and cost. Centralized splitting uses a 132 splitter in a field cabinet for efficient OLT port usage, but requires higher distribution fiber cost. Distributed splitting occurs in multiple stages in the field, reducing fiber deployment cost, but potentially complicating troubleshooting. This image provides an overview of the inside plant, or ISP, design, showcasing the arrangement of equipment rooms, power systems, cooling systems, and cable management within the central office. Thank you for watching this video on FTTH planning and design in GIS. If you found this information useful, please consider subscribing for more content.